Hi guys, today we are going to discuss one of the interesting problems, which is valid anagram. So it is also an interesting problem. So let's try to understand the problem and try to code it. Okay. So what is this question is all about? So given two string s and t. So there are two strings are given. One is s and another is true. Sorry t. Return true if t is anagram to s. So that means if t is anagram to s, then you need to return true, right? Otherwise return false. Now the question is what is anagram, right? So they have defined also what is anagram. An anagram is a word or phrase formed by rearranging the letters of a different word or phrase, okay, typically using the original letters from exactly once. So what does that means? So basically what they are saying, there are two strings s and t. If you rearrange the letters from one of the string, and if you can got another string, then you will able to say that okay, they both are anagram to each other. Okay, so let's look into the example one. If you look into this, so s is like this anagram, suppose, right? And if you will think about this particular t, right? So if you rearrange this t is like this. So if you will do rearrangement of t, or you can do also rearrangement of s also, but let's look into this, right? So if you will rearrange this, so if you take this a to here, this one, right? So then n, so this one is done, right? So let me erase this. So this n, let me take it to here, n is, I have taken this n, then this a here, then this g. So we have created till this point, then we need g. Okay, g is here. Let me take out this g and remove it from here. Then I need r. Okay, r is here, a is here, m is here. So if I'll take all these things, then if you look into these both this string, then what you can see that both the strings are equal, right? So what they are saying, if by doing some rearrangement of these particular things, so if you can go into the s, then you can say that both the strings are anagram, right? So or this is a valid anagram, right? So that is this question is all about. So if you look into this example 2, so if s is like s is your rat, so by doing any of the rearrangement, right? So there is no t here. So that means what, by doing any of the rearrangement, you cannot create the sentence or the word which is rat, right? So you can find r, okay, r is fine, a is fine, but there is no t is here, right? So you can only reach up to this point, ra, there is no t is here. So this is not anagram, so that's why it is returning false. So the basically if you the rearrangement of one of the string is creating another string, then it is known as anagram, right? Now how to code it, right? So now let's think about it, right? So there are different algorithm you can write for this particular problem. So you can pause this particular video and think about how you will solve this problem, and you can comment what are the different approach you find along with the time and space complexity, okay, because this is very important, time and space complexity. Okay, so let's start with the basic idea, right? So basic idea is pretty straightforward, right? So if you'll think about this, right? So the basic idea, if I'll give a hint, right? So the hint is like if you use a sorting, right? So if you use sorting, right? So if you use this sorting, right? Sorting is could be one solution, right? So if you use the sorting, so what you are trying to say, suppose this is your string s, so let's sort it, right? Sort it, right? If you sort it, so how it will look like? So it will be like a, so I'm just trying to sort this string, right? So a, then I think there will be another a, then there will be g, right? Then I think mn, right? I think this is the string, right? This was 3 4 5 6 7 7 letter, 3 4 5 6. I think I missed one. A 3 a's are there. Okay, r I am missing. Okay, so maybe what I will do, r will be at the last, right? Yeah, so r. So this is the after sorting the s. Similarly, if you will sort this particular t as well, then again you will get the same thing, right? If you sort this, you will get that same thing, right? So this is g m n r, right? So again if you just compare, right, s dot compare, right? So compare to t, right? So compare to t, if both are equal, if s, or you can say that if s equal to t, then you can return as true, or else you can return as false, right? So this is the pretty much simple approach which is using the sorting, right? So this is one of the algorithm you can implement, but let's understand the time and space complexity of this one, right? So time and space complexity of this one. What is the time complexity if we'll talk about this one, right? So So you are doing sorting of this, then sorting of this, and again comparing. So I think sorting is going to be dominating factor. So if both the string needs to be same length, right? So if they are equal, so then let's assume that okay, so the length is n, so it is going to be n log n, right? The time complexity is going to be n log n, big O n log n, right? What about the space complexity, right? So I hope you understand, right? So sorting, we are just doing the sorting dominates over all the other things. So then space complexity, there is nothing extra space I am taking, so that's why big of n, big of, sorry, 1. So this is the approach 1. Now the question is, can I reduce this time complexity? Can I get something less than n log n, right? Can I get something? If you want to use some extra space, that is fine, and that is fine. So can you think about this and maybe pause this video again and think about this if you have not thought about anything, and just come back, right? So now the approach is, what is the approach, right? So let's try to understand, right? Again, if you look into this, so this is a classical searching problem, right? So if you look into this, so what we are trying to say, so how many number of a, right? So if you look into this, so what this problem is about, it is all about searching. If there is one a present here, there must be somewhere one a, so that I can just slice this out maybe, okay? So there is another n is present here, though there must be somewhere n is present, right? So this n, maybe suppose I strike it out, right? Now these two are done, these two, another a is present, then a is must be present here, right? So this one, okay. Then there is a r, then there must be a r, there must be a, another a, another a, another a, I am taking it here from m, right? If everything existed from here, everything existed from here, then both the strings are equal, right? Or they are valid anagram, right? So they are anagram, right? So that is the concept. That means what? So we are trying to search every character by character in this particular string, right? So basically what I can say, so then which data structure, can you put it in the comment box? Then if we are searching, then which data structure do you think that you are going to use? Can you put it in the comment box, right? Okay, so definitely if you are trying to search, then map, okay, map is the appropriate data structure. So what we are trying to do, so what I will do now, so maybe I will take out this particular s, string s, so then I will put every character and their count. Suppose a is, initially it is 1, right? Then suppose n comes, then n I will put it as 1, then suppose another a comes, then I will make it as 2, right? Because earlier that was thing. Then g comes, then g I will put it as 1, then r comes, then r I will put it as 1, then another a comes, then I will mark this one as 3, right? Then m comes, then maybe I will put m as 1, right? So after traversing this particular whole S array, or maybe character string, so what I got this particular my map, right? So a occurs 3 times, n occurs 1 time, g occurs 1 time, r occurs n times, m occurs 1 time. So same thing I will do for t, right? Not same thing. So whenever I will see, so when I encounter n, so if n is occurring 1 time, so then I will simply remove it from here, because n is occurring 1 time, right? So this is done. So now I got an a, so that means I will decrement now. Now I will decrement. So that means what? I must see 3 number of a here, right? So that is what we are interested in. So I saw a, so it has count is greater than 1, so it is 3, so I will just simply decrement by 1. So it is 2. Now I see a g, g had a count of 1, that means I can remove this from this particular map now, okay. Now I see another a, so I can decrement this one by 1, right? So I see r, now r I can remove it from this particular map, right? So because r is no more present, right? So if I see a, so again there is only 1, right? So the character count is 1, then I can remove this particular a now, right? Now I see finally m is there 1 time, so that's why I will remove. And finally I will check, is this map is empty, right? If yes, then I am good to go, right? So that means this is an anagram. If the map contains some element, right, then you can say that okay, so this particular thing is a not an anagram. Or in between you find some character like x which is not present. Suppose there is a character x which is not present, then also you can say that this string is not anagram. I hope it is making sense. So let me repeat quickly the approach. Basically put all these things into the hash map along with their frequency. So what you are trying to do, character and frequency, right? So these are the things you are creating a map for the first for the first string, and second string you are just adding it here, and for the second string you are just removing, right? You are just removing, keep on removing. If after removing all the elements, if the hash map is empty, then they all are done, right? So that means this is a valid anagram. In between, if you don't find any of the element present in that particular hash map, then you can say that okay, that is not anagram. Or else after this particular step, if the map is not empty, then also you can say this is not a anagram, right? So this is the basic step. So let's try to implement this one, right? So quickly, so what do you need to do? You need to create a map, right? So before creating map, so if just think about this one, what will be the base condition? You don't need to run all the three if both the strings are does not have equal length, right? If both are not of same length, then it is there is no meaning, just keep on continuing, right? So that's why it is better to add some like base condition kind of thing. If s dot length is not equal to t dot length, right? T dot length, then you can simply return false, right? They are not anagram. If the length is not equal, then definitely the characters frequency are not going to be same. Otherwise what you need to do, maybe you need to create a map, right? Map of what? Character, map of character, right? Maybe character then integer. Okay, so you need to put a character, and integer. So maybe frequency map, right? Frequency new hash map. You need to create a map. Okay, once you created a map, right? So then what you need to do, let's iterate over this particular string, right? So how can you iterate? You can convert this string into an array and do that way, but let me do it in like straight like this way. I hope it is making sense. To char array, let's convert this one to character and go one by one character, right? So what you need to do, so basically you need to, if so this is the thing, right? So what you need to do, if you saw any character, if it is coming for first time, then you need to add it along with the frequency as 1. If it is already present, just increment the frequency, right? So if new char, then add with frequency 1, else add with updated frequency. If frequency updated frequency means frequency plus 1, right? What is the earlier frequency? Earlier frequency plus 1. So that is what you need to do. So let's check if whatever the character you are seeing, if my map dot contains if it contains what, C, right? So if it contains the character, if it does not contain, suppose if it does not contain, then let's add that, right? Let's add that, right? Let's add this particular thing into this character, right? Along with frequency as 1, right? Else, if it is else means what? That character is already there, right? So then what you need to do, then you need to update, right? So you need to update C with the my map, whatever the frequency is already there. How can you get that frequency? Get, right? So this will return you the frequency, my map dot get, it will give you the frequency. Suppose it has already present for 2 times, then it will return true, and then you need to just add plus 1, right? So that is what you need to do. Okay, so this is what you are done with, right? So if it is a new character, you just simply added with frequency 1. If it is already exists, just added with plus 1, right? So that is what you did, and you are done, right? So you are done, you are ready with this particular map once this for loop is done, right? So then you need to put another for loop, something like similar, right? So something like similar. So here you need to, maybe I'll erase all these things. So you need to iterate over all these, not this time you need to iterate over this t, right? So what you need to do, you need to remove, keep on removing, right? So if the character is present, right? So if the character is present, right? So if my map contains, right? If my map dot contains, if the character is already present in this particular map, right? So this character is already present, then you need to check the frequency, right? If the frequency is 1, then you can remove it. If the frequency is more than 1, then you need to reduce, right? If my map dot get C equal to 1, then you can remove my map dot remove. I hope it is making sense. If it is only present one time, right, then you don't need to you don't need to keep on minus, do something, right? Else otherwise my map dot put, right, c comma my map dot get, you can take a variable actually -1, right? So like this, right? So what I'm trying to say, if the frequency is like 3 times, like a was present 3 times and first a you saw, then you are making this as 2 times, right? So because you are removing one a. Okay, so if it is contents, right? So if it does not contains, that means what? So t does not, if you are getting an character, so which is not in the map, earlier map, like here suppose an x is present, right? So let me give an example. You are seeing a character here, trying to suppose x is there and this is not already in the map, that means it is a new character which is not present, that means they cannot be anagram, right? Because this is a new, altogether new character that is not present at all in the s. Okay, so that's why what you will do, so here you can return simply false, right? I hope you are understanding. Else return false. Okay, so this is it, right? And finally once this is done, so this is added all these element and you have removed all these element, and finally you need to check if the hash map still contains some element, then you need to return false, right? That means my map, or it was actually frequency, but I made it as my map. Okay, I'll rename this to my map because I have used that one everywhere. Okay, the size of this particular my map, right, dot size, if it is 0, right, that means I can return true, right? So that means there is every element that is being added here are being removed here also, so that's why I can return true, or else I need to return false. So that is all about it. So I hope you are getting it. So here I am just adding all the element and their frequency. Here I keep on deleting, and in between if I see any extra character which is not present in this particular s, then I can return false. And finally if all the elements are removed, then I will return true or else I will return false. Let's run this particular code and let's see how it works. Okay, so then it is saying that okay, cannot find hash map. Okay, that should be capital M. Okay, that's, there is some more. Okay, okay, my map is contents. Okay, I think it is contents key. Yes, it is not contents, it is contents key. Let's see how it goes. Okay, yeah. Okay, so you need to submit it, so let's submit it. Okay, let's see. Okay, it is passed. Okay, it is passed. Okay, so let's see. So this is how it works, right? So one solution that we found, that is order of n log n. So if you look into the previous solution, right, so the sorting one, so that we have already discussed, so that algorithm was order of n log n, that special the time complexity, and order of 1, right, the space complexity, right? So now if you look into this particular algorithm, so this is a single for loop iterating over this same character and putting it, right? So these are all order of 1 time complexity, because this is dealing with map. That is the beauty of map, right? So this is also again, so this is overall order of n, this is overall order of n, or maybe n you can say. So that's why the time complexity is going to be order of n. Okay, the space, but here there is a space complexity which is order of n, because we are taking an extra map, right? So which is of length no sorry so yeah, so this is the question, so whether it will be actually order of n or order of constant, right? So the space complexity, so the most of the people answer actually order of n, but it is not order of n, it is going to be order of 1. Why? Because if you think about this my map, so it cannot go beyond the size of 26, right? So because we are just putting the character, right? So only characters are being put as the key and then the frequency, so there can be 26 number of character, right? So if you will take positive like small character, big character, then also then it is going to be 26 plus 26. So that's why this hash map size cannot be greater than 26 plus 26 at any point of time, right? So this can be only 52 at any point of time, cannot be more than that. So that's why the time space complexity is not order of n, rather it is going to be order of 1. So that's why this algorithm 2, which is algorithm 2, so which is going to going to take how much time? So it is going to take order of n time complexity, and again space complexity remain the constant. So that's why this is a better approach, right? So that's all about this. You can do little bit actually improvement of these things, right? So you can do a little bit improvement, like here you can use some method like getter default, right? So you can improve this. Then like here you are instead of like doing this, so there is a, you can read about get or default, right? Get or default, there is a method, so that you can use in order to just reduce your code, right? So like you can write like this, right? So if you don't need to write like this, just like my map dot put, right? Then what you need to do, c comma my map dot get getter default, right? So it takes two argument, one is c comma default argument is 0 then plus 1, right? So like this, right? Default argument is 0, then you need to plus 1. That means what? So if the character is not present, then this is going to be return 0, otherwise it will return the frequency. Then you want to add it, right? First time you are adding it, then you need to put it as 1, or second time like you are doing first time, it will put it as 1 because 0 it will be returning and just plus 1, or else it will just frequency then plus 1, right? So you can remove this piece of code, you can run also now like this, okay? So this should work also, right? So there could be some improvement like here as well, so you need to look at this, but again the time complexity and the space complexity is going to remain same, there is no change, okay? So this is all about for this particular valid anagram. I hope you enjoyed video. So if you have enjoyed video, just please put it in the comment box, and don't forget to subscribe and press the bell icon and share with your friends. Thank you so much. See you in the next class. Bye. Take care.